Swayam Prabha. Digital India. Educated India.
Good morning, friends. Today we are starting with we are continuing our previous session, that is on plant location. This is a course on production and operations management, and we are at unit 3, that is plant location. In the previous lecture we discussed the importance of plant location, and also we studied how to evaluate the various alternative locations. In that series we studied the technique that is called decision matrix or linear decision rule, where by identifying the various factors which are important in deciding the location of a problem, we give the relative importance to those factors, and then we rated the various alternate locations on the factors, and at the end we calculated the weighted score. The fact that the location which is having the highest weighted score was selected for the purpose of factory location or facility location. Today, continuing on that, we will study another technique of evaluating the alternatives. In this technique, which is named as break-even analysis, in this technique we will consider two types of cost. One is called fixed cost, another is called variable cost. So, it is a totally quantitative method, there is no qualitative parameter attached in this particular technique. So, we will see that again, as I said in the previous session, that for any decision making situation to arise, we should have the presence of alternatives. So, here also we should have the presence of alternative, and our objective function in this case is minimum total cost. The total cost of fixed cost and variable cost should be minimum. So, that is our objective in this case. Now, let us see the procedure part of it, and before procedure let us understand what is meant by fixed cost and what is meant by variable cost. The fixed cost is that cost which remain constant and it is independent to the quantity produced. So, in a way fixed cost is independent to the quantity produced. If you are a factory producing something, there are certain types of cost which you have to incur, whether you are manufacturing 100 units or you are manufacturing 500 units or you are manufacturing the full capacity of the manufacturing plant. These costs includes the salary of the senior management, the rent paid on the premises, interest paid on the capital borrowed, property tax, depreciation of machine, etc. So, these are some of the expenses which you have to incur, whether you produce something or you do not produce something, or whatsoever may be the quantity produced, these expenses are going to be incurred. Okay. So, this is called fixed cost. Similarly, in a machine, if you are purchasing some technology, if it is a manual activity, the fixed cost may be very small or may be negligible, 0. On the other hand, if you are having a fully automatic machine which is very expensive, then the depreciation of that machine and the cost of capital of that machine will be the fixed cost, and also the space occupied by that, the cost of space which is occupied by the equipment, that is also a part of the fixed cost. Coming to the variable cost is that cost which varies with the quantity produced, that means it is the cost of raw material. If you are producing 100 units, the raw material equivalent to 100 units is required. If you are producing 500 units, then the raw material equivalent to 500 units is required. Similarly, the transportation cost of the materials, whether it is a raw material or finished products, or it can be salary of the casual workers which you are keeping depending upon the workload. Whereas, if there is a regular employees, you have to pay the salary, then it will be a fixed cost, but casual employees, contractual employees which you are keeping as and when required, then it can be a variable cost. Friends, a fixed cost does not mean that it will remain constant for 0 to infinity kind of a thing. Many times it is a step function also, but here in this analysis we are considering that it will remain fixed for the quantity under consideration. Okay. Like we can draw like this the quantity versus cost diagram. the fixed cost is independent to the fixed cost is independent to the quantity produced. On the other hand, the variable cost varies with the quantity produced. Variable cost varies with the quantity produced. If we combine these two curves together, then this is a curve which line which will go parallel to the variable cost, and this will be line of total cost. Total cost means total of fixed cost as well as variable cost. So, like this. So, and as I said, many a times your fixed cost can be like this also, quantity versus cost. It can be like this. For a certain amount of quantity produced, it is like this. After that, you may have to add capacity or maybe some other resources or something like this. So, here in this case, we are considering that we are working in this particular zone only. So, that means our fixed cost is constant independent to the quantity produced. So, now the remaining 2 points I have already elaborated here. So, plot the total cost, first plot the fixed cost, then plot the variable cost, and then we can plot the total cost and determine the lowest total cost. That we will do in our subsequent slides and subsequent discussions. So, break even analysis is one which consider two types of cost, one is fixed cost, another is variable cost, and our idea is to select a location where the total cost of total cost, that is fixed cost plus variable cost, is minimum, and fixed cost is that cost which is independent to the quantity produced, whereas variable cost is that cost which varies with the quantity produced. Now, let us move forward. The break even analysis is carried out in two steps. The first step is called accept reject step, and second step is called selection of the exact location. So, in the first step, let us say take this small example. We have decided 4 alternate locations. We have decided 4 alternate locations, that is location A, location B, location C, and location D, and we have collected the data about the fixed cost as well as the variable cost. For location A, fixed cost is 2,50,000 and variable cost is 11 rupees. We can say, we can write the units also, it is rupees per unit, and this is rupees per annum. So, fixed cost as a unit of rupees per annum and annual cost, and variable cost is rupees per unit. Location B has a fixed cost of 1 lakh and variable cost of 30 rupees. Alternate C, location C has a fixed cost of 1,50,000 and variable cost of rupees 20 per unit, and location D has a fixed cost of 2 lakh and variable cost of rupees 35. This information can be easily taken from the costing department, and they maintain all such kind of data, and they can very easily provide us the numbers. I also assume that for this particular situation, the selling price of the item is rupees 60 per unit and the annual demand is 15,000 units. Now, step 1, the step 1 is accept reject decision. That means, I have to see that the break even point of these alternatives is lesser than the annual demand of my products. If any alternative having a break even point higher than the annual demand, then that alternative need not to be considered for the second stage, it should be rejected at the first stage itself. So, stage 1 or step 1 or stage 1 is the accept reject decision. There we will see the break even point of these alternate location vis-a-vis the annual demand. If the annual demand is lesser than the break even point, that alternative we have to reject. So, let us calculate. The formula for calculating the break even point is written here. The break even point for accept reject decision is equal to fixed cost divided by selling price minus variable cost. So, for location A, the break even point will be equal to, our fixed cost is 2,50,000, selling price is rupees 60 and the variable cost is rupees 11. So, this will be equal to 5102 units, and this is lesser than 15,000. So, decision is accept the location. Location is good, location is useful. Here we are doing the independent evaluation of that particular location. Okay. Now, similarly, let us see for location B, the break even point is equal to, what is the fixed cost? 1 lakh. What is the selling price? 60 rupees for all, because they are we are going to produce the same type of product. So, the selling price will be constant and minus the variable cost, that is rupees 30. So, break even point turns out to be 3,333 units per year. Okay. So, if my demand is more than 3,333, I will accept this location also. So, this location is also accepted. Okay. Now, let us see the location C. The break even point of location C is equal to the fixed cost, that is 1,50,000, the selling price rupees 60 and the variable cost rupees 20. So, the break even point for this situation is 3750 units per year, and this is also more than the our annual demand, lesser than the annual demand. So, this is location is also accepted. Okay. Now, let us do the location D. For location D, the break even point is equal to 2 lakh is my fixed cost and 60 is the selling price and 35 is my variable cost. So, my break even point turns out to be 8,000 units, and this is also lesser than the annual demand. So, this is also going to be accepted. So, from this the decision is all the 4 locations are accepted for further analysis, that is stage 2. Okay. So, the decision is, as I have said, check the break even point of each alternative location and compare it with the annual demand. If the break even point is less than the annual demand, the alternative is feasible and acceptable. So, in our case all 4 alternatives are acceptable, and so now we are going to the next stage, second stage of this analysis. In the second stage, graphically we will represent the fixed cost, variable cost and the total cost. Let us do that also, it is not very difficult, very simple to do. On this side is quantity, on this side is cost. Alternate A, let us draw some kind of a scale here. This is let us say 1 lakh, 2 lakh, 3 lakhs. Okay. So, alternate A 2.5, 2.5 is the fixed cost and 11 rupees is the variable cost. So, graph will go like this, the slope is slightly less. Alternate B, the fixed cost is 1 lakh, but variable cost is very high. So, the slope will go like this. So, this is, let me mark also, this is my alternate A and then this is my alternate B. Let us see the alternate C. Alternate C, the fixed cost is 1,50,000, somewhere in between, and variable cost is 20. So, the slope will be in between these two slopes. So, we can mark it like this, not very good. Let us do it again. Okay. So, slope should be slightly lesser than this. So, it will go like this. Okay. And then this is my C, and let us see the D. D, the fixed cost is 2 lakh and variable cost is 35. So, let us change the color also, take select green. So, 2 and so this will go like this, D will go like this. So, this is how we can plot the fixed cost and the variable cost. Deliberately I have not drawn the line of fixed cost, it will be parallel to the x axis, because this is independent to the quantity produced. So, this is how we can produce the diagram. So, I have drawn it also, kept it also in this manner, so that it is a better representation. You will be able to, the same graph is already I have produced. So, you can see here. So, what you will find, the one of the break even point is coming somewhere here, which is a intersection of A and C. So, the first break even point, this is also called point of indifference, is coming between A and C, second, sorry, not A and C, between B and C. Between B and C, this intersection is between B and C, and second, this another intersection is coming between A and C. A and C, B color is that is slightly lighter color. So, you will be able to see that. So, second intersection is coming A and C. Now, in the next step we will find out the value of this. What does this indicate? If we see this point, below this point, if the quantity is lesser than this, B is superior, if the quantity is more than that, C is superior, and if the quantity further exceeds, we find A is superior, because the total cost of A is lower. In this zone, the total cost of C is lower. In this zone, the total cost of B is lower. So, this is how this second step is, we will calculate the point of indifference or the break even point. Let us see. So, this is step 2 or phase 2, stage 2 of the identifying the location. So, now calculate the point of intersection of the lines, that is break even point, or this is also called point of indifference. And how to calculate? Very simple formula. Break even point between A and B is given by fixed cost of A minus fixed cost of B divided by variable cost of B minus variable cost of A. So, this is how we can calculate the and this is very easy to determine this formula also. Let me give you that also. We have to, if we are comparing two locations A and B. So, what we will do? Let us say quantity x is the break even point or point of indifference. Quantity x is break even point, or better term for this is point of indifference, where both the alternatives are equally good. There is no difference between the two alternatives. So, this is given by, like let us say comparing A and B to find the point of indifference between A and B. Total cost of A will be 2,50,000 plus 11 into x, and this is should be equal to, at the point of indifference, this should be equal to 1 lakh plus 30 into x. So, from this x is equal to 2,50,000 minus 1 lakh divided by 30 minus 11, that is fixed cost of A minus fixed cost of B divided by variable cost of B minus variable cost of A. So, this is how we can calculate, and this formula has been derived in this particular way only. Now, let us see. So, in the previous slide we said that we have to find out the point of intersection of B and C, and also we have to find out the point of intersection of A and C. So, let us see, let us write here B and C and then A and C we will calculate. For B and C, the point of intersection, what is my fixed cost of B? Fixed cost of B is 1 lakh, fixed cost of C is 1,50,000 divided by variable cost of C, that is 20, minus variable cost of A, that is 30. Okay. So, this is minus 50,000 divided by minus 10. So, point of indifference is 5,000 units. So, 5,000 units per year is the point of indifference. If your demand is 5,000 units per year, then both alternative B and C are equally good. The total cost of B and C will be same. Now, let us just see here. So, this will be approximately, if we extend this, we will find this is 5,000. Okay. So, this is how we can calculate the point of indifference. Now, see between A and C. Same way we can see between A and C. Let us change the color also. Between A and C, the break even point or point of indifference, the fixed cost of A and C. So, this is 2,50,000 minus 1,50,000 divided by 20 minus 11. 20 minus 11, and this turns out to be 1 lakh divided by 9. 1 lakh divided by 9, and this will be 11,111 units per year. So, that is my point of indifference. So, returning back to our this diagram. So, this is around 11,000 is the break even point. So, decision is very simple. If the quantity requirement is lesser than 5,000, B is preferred, location B is preferred. Obviously, you will find that when the quantity is very small, the alternative which is having the least fixed cost will be preferred. It is just like a manual technology. If the quantity is less, the alternative which is having the lowest fixed cost will be selected. After that, you will find C is there, the alternative which is having the next higher fixed cost, and then we are having the alternative which is having this. You will find that alternative D is not good for any quantity. Alternative D, which is given in the blue color, is not good for any of the quantity, because its cost is always, the total cost is always more than the any other alternative. Always there is, for every quantity there are other alternatives which are having a total cost lower than this. So, alternative D is not a good option for anyone. So, but otherwise we can choose B. If my requirement is, demand is lesser than 5,000, I can go for alternative C if my demand is between 5,000 to 11,000, 11,100, and if the demand is more than that, then I will select. For a higher demand, the alternative which is having the least variable cost is always selected. For the higher category of demand, the alternative with the least variable cost is always selected. For the lower quantities, the alternative with the least fixed cost is always selected. So, this is more like a thumb rule. Even without this analysis also, you can find out if the quantities are less, I should choose a alternative which is having the least fixed cost. If my quantities are more, I should pick a alternative which is having the least variable cost. So, this is how this break even analysis can be carried out, and based on this you can decide which particular location I should go for, depending upon the demand of your products at that point of time. Now, let us see the third method. So, first we have said decision matrix in our previous lecture. Now, today we have studied in this particular lecture break even analysis. Now, let us study the third technique, that is Brown and Gibson method, which was given by two gentlemen, two researchers, Brown and P. Brown and D. Gibson. This is a multi-attribute decision making problem where we are having three types of factors. One is a CFM, critical factor measure. They are the critical factor which has a value of either 0 or 1. Some factor, if it is present, you are considering the location. If that factor is not present, you are not considering. The value is 0 or 1. Just like if political stability is not there, other factor may be anything, but I am not going to consider that particular location if the political stability is not there. If there is a high trade unions, I will not select that location, whatsoever may be the other benefits of that location. So, that is called critical factor. So, if the critical factor is not present, I am not considering that particular, and that is why in the formula it is coming as a multiplication of all other evaluation. So, if this all other evaluation is multiplied by 0, it will become 0. The score of that particular location will become 0. And if it is 1, then that means this is present. So, we will see the scoring of the other factors. Then we will consider some objective factors. We will consider some objective factors. Objective factors, those which can be measured in the form of cost, which can be quantified. And we will also consider the subjective factor measures, the factors which are subjective in nature, it is difficult to quantify, we will rate them on a scale of 0 to 10 or 0 to 100. Okay. So, these are subjective factors. Another thing which is a parameter D, we have to decide how much importance I should give to objective factors and how much importance I should give to the subjective factor. If I am giving importance of, and so the value of D is between 0 and 1, the value of D is between 0 and 1. If I give a value of 0.6 here, then the subjective factor will have a value of 0.4. So, this is D and this is 1 minus D. So, if I giving importance D to the objective factor, then 1 minus D will be the importance to be given to the subjective factors. So, this whole thing is written here. Let us understand this also. So, LMI is the location measure of alternate I. So, here again we are having some alternatives which we want to evaluate. Then critical factor measure, which could be either 0 or 1 for an alternative I. OFM, it is a objective factor measure which could be between 0 and 1. However, the sum of all objective factor measures for different alternatives should add back to 1. Similarly, subjective factor measures which measure the subjective factors, and then D is the importance or the weight given to the objective factor, and 1 minus D is the weight given to the subjective factors. And we will select the alternative whose measure LM is highest. We select the alternative for which the LM value is the highest. Let us take one example. So, what are the steps? You have you have designed your own steps also, but let us read it also. So, first is identify the alternatives, then identify the factors which affect the choice of location and classify them as critical, subjective and objective factors. Find the relative weights of the factors, how much weight you want to, what is the relative importance of these subjective factors and objective factors, we will do that. For objective factor, find the cost data for each alternative and calculate the objective factor measure for each alternative. For subjective factors, compare the alternatives. Here we are not having the cost data, but we will do a subjective comparison and calculate the subjective factor measures for each alternatives. Step 6, decide the relative importance of subjective and objective factors and then calculate the location measure LM for each alternative. Alternative with highest LM is selected as the best location. So, this is the procedure part of it, though it is a very simple procedure. Select the alternative, select the factors, divide the factors into 3 categories: critical factors, objective factors and subjective factor. Critical factors, if that is not present, it will get a value of 0, if it is present it will get a value of 1. Objective factors, they can be measured in the form of cost, they can be quantified in the form of money, whereas subjective factors, they cannot be quantified, we can only compare them which factor is more important as compared to other factor. And then after doing that, we will calculate the location measure by giving the due importance to objective factors and the subjective factors, and the location which has the highest location measure M is going to be selected. So, take one example. The critical factor is political stability. Objective factors are manpower cost, transportation cost, electricity cost and taxes. All these factors can be quantified in terms of money, rupees per year. And then subjective factors, educational institution and housing, basically civic amenities, recreational facilities and culture. We can take other subjective factors also, like availability of skilled manpower can be another subjective factor which could have been written here, or it can be some other factor also which is not critical, like trade unions or some other factor. Climate can be considered as a subjective factor here. But for the sake of simplicity, we have kept very few factors here, but technique has no limitations. You can consider as many factors as you think are relevant for given decision, for the given nature of the factory, nature of the facility. So, this is the data available with us with respect to the objective factors. We are having 4 objective factors: OF1, OF2, OF3 and OF4. As said earlier, manpower cost, transportation cost, electricity cost and taxes. And we are considering 3 locations: location 1, location 2 and location 3. And this is the cost data available with us for these 3 locations. This is the cost data, basic data available with us for these 3 locations. Since the unit of all these cost is same, we can consider them as one factor, that is a total cost. So, total cost of alternative 1 is 580, alternative 2 is 470, alternative 3 is 580. In this case, since lower the better, it is a cost. Cost means lower the better. We will take the reciprocals of them, and then add them and then reciprocally. So, that way we get a factor of this factor 0.005561. I am repeating, we will take the reciprocal of these costs. Why we are taking reciprocal? Because cost lower the better. So, if we take the reciprocals, the number which is higher, that will be better. So, we take the reciprocals of them, and then we will calculate the objective factor measure by using this very simple formula, that is 1 by a total cost of location 1 multiplied by this factor 1 by C, and this gives us objective factor measure for location 1 is equal to 0.310. Similarly, for location 2, same way 1 by 470 into this particular factor, that is 0.383, and for location 3, 1 by 580 into this, we will get a objective factor measure for location 3 as 0.307. So, we will reproduce these 3 numbers again. Now, let us see how to calculate the subjective factor measures. So, friends, here we have considered 3 factors, that is SF1, SF2 and SF3. It is a pair comparison technique. We will compare factor 1 with factor 2, then factor 1 with factor 3 also, and then we will compare 2 with the 3 also. So, when we are comparing SF1 with SF2, we write 2 numbers together. If 1 is more important than 2, we write 1 here and 0 here. On the other hand, we compare 1 with 3, then we will write this particular pair. We find that 1 is more important than 3. So, we write 1 here and 0 here. Here in this cell we are comparing 2 with 3, and we find 2 and 3 are equally important. 2 and 3 are equally important. So, we write 1 here as well as 1 here. So, this is how we can do the pair comparison of these alternative subjective factors, not alternative, these subjective factors. So, now we make a total of this. 1 plus 1 is 2, 1 and 1, total is 4, and this is the weightage. 2 divided by 4 0.5, 1 divided by 4 0.25, and total comes out to be 1. So, this we have find out what is the relative importance of these subjective factors. Now, we are doing the scoring of the alternatives for subjective factor 1. For subjective factor 1, we will see that which particular location is better. So, we compare again in the same manner location 1 with location 2, and we write 1 here because location 1 is better than location 2. We compare here 1 with 3, and we found that location 3 is better as compared to location 1. Then we compare location 2 and 3, and we find location 3 is better than location 2, and again do the totaling of this score, and in this manner we get that location 1 on this particular factor S1 SF1. On factor SF1, location 1 has a score of 0.33, location 2 has a score of 0, location 3 has a score of 0.67. Now, let us see for the second factor SF2. For the second factor SF2, again the same manner, compare location 1 and 2. Location 2 is more important. So, 1 is written here, 0 is written here. Now, compare location 1 and 3. We found that location 3 is more important. So, 0 is written here and 1 is written here. Here we compare location 2 and 3. Location 2 is more important. So, 1 is written here and 0 is written here. And again we make a total row wise total 0, 2 and 1, and we then calculate the relative scores of locations. So, on the recreational facility point of view, location 2 is the best location, location 3 is the second best, and location 1 is not very good location from the recreational point of view. In the same manner, we will compare the three alternatives on the third factor, that is culture. On this point, we will find that again compare, we find 1 and 2 are same, whereas 1 and 3 when we compare 3 is better, and when we compare 2 and 3 we find 3 is better. So, in that way if we are doing the scoring, this is the score which we will get, relative score of 3 locations on the subjective factor culture. So, this is how we can do that. Now, bringing them together, all the 4 tables together in one last table, synthesizing the table 1, 2, 3 and 4 together here. Let us change the color also of the ink. So, this column will come from the table 1. The weightage is given to various subjective factors. Subjective factor 1 has a weightage of 0.5, subjective factor 2 has a weightage of 0.25, subjective factor 3 has a weightage of 0.25. So, this. Now, the scoring, now we can see the row wise. This particular row will come from this side. On the subjective factor 1, the scoring of location 1 is 0.33, location 2 is 0 and location 3 is 0.67. So, this will get from the table 2, and similarly this data we are getting from table 3 and this data we are getting from the table 4. Okay. So, table 4 0.25, 0.25 and 0.50. And now, next step is to calculate the weighted score. Let me erase all this ink from the screen. Now, how to get this number? 0.5. So, 0.2275, how we have got 0.5 into 0.33 plus 0.25 into 0 plus 0.25 into 0.25, and that gives us 0.2275. Similarly, for location 2, similarly for location 3. So, these are my location alternatives. These are my location alternatives. Okay. So, this is how we get this scores of these 3 alternatives, and out of this now we are what we are observing, that the score of location 3 is the highest. Score of location 3 is the highest. So, we can select this location 3. So, friends, this is the procedure part of the Brown and Gibson method, where we divide we have to continue. This is the subjective factor so far we have calculated. This is the best location from the subjective factor perspective, not from the overall perspective. Overall perspective we will see in the next slide. So far we have calculated the objective factor measure, we have calculated the subjective factor measure for all the 3 alternatives, and we assume that the critical factor measure for all the 3 location is equal to 1. That means, all the 3 location qualifies as far as critical factor is concerned. Okay. And further we assume that we are giving a weightage of 2/3 to the objective factors and 1/3 to the subjective factors. Keeping that in mind, now we will calculate the location measure for location 1, 2 and 3. For location number 1, 0.67 into 0.310. 0.310 is the objective factor measure of location 1, and this is a subjective factor measure for location 1. So, by this combining this we get the score for location 1 as 0.2828. In the same manner, the score for location 2 is 0.3325 and the score for location 3 is 0.3847. And in that manner, we found that location 3 is the having the highest score. So, location 3 is selected. So, this is a brief about Brown and Gibson method, by which we can compare the alternative locations on parameters. The parameters are divided into 3 categories, that is subjective factors, objective factors and the critical factors. Now, as a fourth technique, we will talk about Bridgman's dimensional analysis. Very important, very useful technique, and having vast applications also, not only in the plant location area, it can be applied in other areas also. This was developed in 1963 by Bridgman, and as the name suggests, dimensional analysis. We do the analysis of various dimensions of a given location or a given alternative. One of the fundamental results of dimensional analysis is the so called Bridgman's theorem. This theorem states that the only functions that may have dimensional arguments are products of powers of the base quantities of a given system of units. We will understand that. That means, if you are having two alternatives and on dimension 1 we can say x 11 divided by x 12. So, x 11 is the value of dimension 1 for location 1 and x 12 is the value of dimension 1 for location 2 and w 1 is the weightage of dimension 1. So, this is how we say that for any alternative which is having the dimensions, they may have a dimensional argument or products. So, we have to multiply product of second factor x 21 divided by x 22 the power w 2 like this, product of the powers of the base quantities of a given system of units. So, this is how this kind of formula we are going to use in Bridgman's dimensional analysis, a method of making integrated comparison of alternatives on the basis of tangible and intangible cost. These factors can be tangible, these factors can be intangible also. When criteria are interrelated, but cannot be represented in the same dimension, we can use this analysis. So, it is not necessary that all my dimensions are of the same nature, like in it can be in the form of cost also, it can be in the form of other availability of the labor, it can be in the form of electricity quality, or it can be with respect to political stability. So, any such dimension can be considered here, criteria can be considered here. So, procedure is simple: identify the alternatives, identify the factors or criteria, find the relative weights of the factor, we can use pair comparison technique, prepare utility payoff matrix for tangible factors in rupees and intangible factors on a scale of 10. 1 means the most desirable, 1 being the most desirable. It is taken because in the cost also lower means most desirable, because cost means the alternative which is having a least cost is the most desirable. So, similarly for intangible factors also we consider least cost is most desirable. So, least number is most desirable. So, 1 is most desirable here. Step 5, calculate the ratio R. The way I was calculating ratio R of factors value of alternatives 1 in numerator and alternative 2 in denominator, and if R is lesser than 1, alternative 1 is selected. So, we use this formula as I was trying to write here in our previous slide. So, R 12 is equal to x 11 by 21, x 21 by 22, x 31 by 31, and this is the weightage given on this. So, preference for alternative 1 divided by preference for alternative 2. Okay. So, this is how we are going to do, and this is the payoff matrix where we are having the factors here, factors 1, 2 and 3, and these are my potential alternatives. 4 alternatives I am having, 4 alternatives I am having, and then this is the relative importance of my factors. Factor 1 has importance of W 1, factor 2 has a importance of W 2, and factor 3 has importance of W 3. So, like this. So, this is how this is the formula. Let us see one example also. Suppose we have considered these factors. One is land and equipment, which is a quantitative factor, labor cost per year another quantitative factor, taxes another quantitative factor, 4 culture as a subjective factor, climate as a subjective factor, and skilled manpower as a subjective factor. So, 3 objective factors and 3 subjective factors we have taken, and then for the objective factors we have calculated the cost in million of rupees. 250 million is the cost of land and equipment annual cost in the form of it can be initial cost also, it can the annual cost also, depending upon how you want to consider this parameter. So, here in this case it is not necessary that we should consider the annual cost, we can consider even one time cost also here, and then the weightage you can say that one time cost how much weightage you want to give, and if there is a annual recurring cost then how much weightage you want to give. So, here we are considering for the clarity purpose, this is my initial cost of land and machinery, initial cost of land and machinery. So, 250 million is required in land and machinery to set up the factory, and 150 million is required at location 2. Labor cost per year 5 million for location 1 and 8 million for location 2, and taxes 0.8 million for location 1, 0.6 million for location 2, and this culture factor we are comparing on a scale of 0 to 10, and I found that culture point of view location 1 is better because it has a score of 2, location 2 is not very good, it has a score of 7, lower the better. And climate, this location has a better scoring, and for the skilled manpower perspective location 2 is having a better scoring, and this is the weights we have given. We can use pair comparison technique to identify these weights. So, we are not repeating that here. Now, we will calculate the score R 12. We will calculate the score R 12, that is 250 by 150 raised to the power 3, 5 by 8 raised to the power 4, and so on like this, and we get a score of 0.55. Since the 0.55 is lesser than 1, so we will select the is less than 1. So, location 2 is better, we will select the location 2. So, this is how we can compare the 2 locations with the help of this. The only limitation of this technique is at a time we can compare only 2 locations, whereas in our other previous Brown and Gibson method, decision matrix and break-even analysis, we were able to compare as many locations as we have considered in one single go, but here we have to consider them in pairs, and then the one which is now in this case we will not compare one with any other location, we will compare 2 with 3, and then we find again 2 is better, then we will compare 2 with 4 like this. So, we can do that in pairs, and based on that we will see that at the end the which particular location is going to survive, is going to beat all other locations, and that particular location we are going to select. So, friends, we have studied these 4 techniques by which we can evaluate the alternatives, and these are the techniques when the location is independent. You are independently deciding the location, where is no previous other facilities are there. So, in that context we are selecting the location. Now, there are another set of location problems which can exist, where some you want to set up the new location with respect to some existing location, because your new location is either going to get the inputs materials from the existing location, or your new location is going to supply to the existing location. So, in both the cases you have to consider, or there may be both together, you want to consider the existing sources of supply as well as the existing markets or your warehouses, and based on that you want to decide the location of your new facility. So, in that context this second set of techniques we are going to study in our next lecture, where the examples can be location of a warehouse for existing factories and sales point. you are having sales points and markets, and you are having some existing factories, and you want to set up a warehouse which will collect the material from existing factory and then supply to the various sales point. So, that can be one example here in this category of this is also called popularly called single facility location. Single facility location. You want to set up one single facility which will meet the requirements of existing facilities. Then there can be a case of setting up of a blood bank for serving the existing hospitals. You are in a city of Delhi or in a city of some metropolitan city, there are some hospitals or some is already existing, and they are of different capacities also, sizes also. The size of the bed we are saying that is a surrogate measure for the requirement of blood, and based on that we can decide where I should locate my blood bank. So, that the total distance travelled to meet all the requirements is minimum. Here also in the first example also we want to set up a location of the warehouse, so that the total transportation cost is minimum, or the total distance travelled distance weight distance unit is minimum. Third can be tool room for serving the existing manufacturing facility. I have written 3, but there may be several such kind of examples where we have to consider the location of a single facility to meet the some existing facility. And we will study some techniques also, load distance technique, transportation method. We will develop a mechanical analog also, and then we will use gravity method and the medium method in our next lecture. In the next lecture we will also have a brief discussions on location for service organizations, location for service organization as well as location for emergency facilities like police station, fire brigade. We will talk about that also. Thank you very much.
Hello and welcome to this piece of literary snippet. As a student of English literature, the kind of poetry that we are most likely to encounter is perhaps the sonnet. Now, a sonnet, as some of us might already know, is a poem which is composed by putting together 14 lines of verse, and this style of poetry was first popularized by a poet named Petrarch, who lived in Italy during the 14th century. Now, legend has it that Petrarch once saw a very beautiful lady by the name of Laura, and Petrarch was so enamored by the lady that he wanted to compose poems to celebrate his love for her. But there was a problem, because marriage was impossible. Petrarch himself was an ordained priest, and that prohibited him from marrying, and the lady herself was a married woman. But nevertheless, Petrarch went ahead to immortalize the beloved and his love for that lady in poetry, and the form that he chose was the sonnet. Since then, sonnets have traditionally been written about ladies who are of unparalleled beauty, and about poets who are hapless lovers and who know that their love for their beloved would have to remain unrequited forever. Now, in England, the sonnet form came around 16th century, and its first practitioners were people like Sir Henry Howard, the Earl of Surrey, and Sir Thomas Wyatt. However, it was William Shakespeare who was to prove the greatest of English sonnetiers. And in fact, the charm of those sonnets that Shakespeare wrote 400 years from now still can be felt. And if I read out to you one of Shakespeare's sonnets, you'll appreciate this better. This sonnet is usually known by the title, "Shall I compare thee to a summer's day?" which is also the first line with which the poem begins. Shall I compare thee to a summer's day? Thou art more lovely and more temperate. Rough winds do shake the darling buds of May, and summer's lease hath all too short a date. Sometime too hot the eye of heaven shines, and often is his gold complexion dimmed, and every fair from fair sometime declines, by chance or nature's changing course untrimmed. But thy eternal summer shall not fade, nor lose possession of that fair thou owest. Nor shall death brag thou wanderest in his shade, when in eternal lines to time thou growest. So long as men can breathe or eyes can see, so long lives this, and this gives life to thee. Now, as you might have noticed, that very much like the Petrarchan sonnet, this poem too speaks of an idealized lover who is more beautiful than a lovely summer's day. But also notice how, in the last few lines, the poem subtly shifts from praising the beloved to praising the poet himself. It is the poet who is going to produce the lines of poetry which will preserve the beloved's glory forever. And people will continue reading them even after the beloved has died. As the last couplet of the poem suggests, so long as men can breathe or eyes can see, so long lives this. And here this, of course, refers to the verse that Shakespeare composes and which we are reading today, 400 years later. So long lives this, and this gives life to thee. Shakespeare is well known for these kind of subtle plays with the conventions, these kind of subtle reversals of what is expected conventionally. But nothing is more striking than the sonnets that he composed on a dark lady. In these poems, we do not meet the traditional fair, idealized beauty, but rather a woman whose appearance might even be described as ugly. Here is a sample. My mistress's eyes are nothing like the sun. Coral is far more red than her lips is red. If snow be white, why then her breasts are dun. If hairs be wires, black wires grow on her head. I have seen roses damasked red and white, but no such roses see I in her cheeks. And in some perfumes is there more delight than in the breath that from my mistress reeks. I love to hear her speak, yet well I know that music hath a far more pleasing sound. I grant I never saw a goddess go. My mistress, when she walks, treads on the ground. And yet, by heaven, I think my love as rare as any she belied with false compare. As you can see, the beloved described in this poem is nowhere as beautiful as a beloved of the first poem. Yet, the point that Shakespeare is making here is that though the image of the beloved is not as beautiful as it was in the previous poem, it doesn't stop her from being an object of love. Love, Shakespeare insists, has very little to do with the outward appearance of a person. And in many ways, this de-idealized beloved is perhaps a person with whom a more intimate engagement is possible. She's definitely a more human person, a person who treads on the ground just like all of us do. See you in the next episode of Literary Snippet.